Hi everyone. The next topic that we are discussing is logarithms. So the first question, log of 75 upon 35 plus 2 log 7 by 5 minus log of 105 upon x minus log of 13 upon 25 is equal to 1. Obviously, we have to find the value of x. Now for this question, the first step that you should do is restructure this entire expression. So the first and second term, let's put it together and put a bracket, and for the third and the fourth term let's do the same thing. So when we do that, obviously what we end up having is log of a plus log of b in both the brackets. Log of a plus log of b, we know the formula, it should be log of ab. And also in the second term, if you see, the term is 2 log 7 by 5, so obviously the step before that would have been put that 2 back in the power position of 7 by 5, because that is why the 2 has been uh, brought forward because of the power wala rule. So log of m raised to r is r log m, that r power comes ahead. So put that 2 back also as a square of 7 by 5, and then use log a plus log b property. When we do that, this is what you will have. And now what we have is log a in first bracket minus log b in the second bracket. So for addition, if we are going to multiply the terms, then obviously for subtraction, we should divide them. So log of a minus log of b is log of a upon b. So all we need to do is divide this and cancel out the common multiples from both numerator and denominator. When you are done with that, what you will be end up with, log of x upon 13 is equal to 1. Now think of this, the value of x is 130, because 130 upon 13 will give you 10, and log of 10 to the base 10, the answer is 1. So it matches with the right side. So the answer, that is the value of x in the first question, is 130. The second one, 1 upon log xyz to the base xy plus log xyz to the base yz plus 1 upon log xyz to the base zx. Use change of base and you will be done with this question in a no time at all. So when you apply change of base, you will get log xyz upon log xy in the denominator, log xyz upon log yz in the second term, and log xyz upon log zx in the third term. Then all the denominators will flip and go up, and you will be getting log xy upon log xyz plus log yz upon log xyz plus log zx upon log xyz. All the denominators are same, which is log xyz. That means numerator should also be added, but in log we don't add, we will multiply. So when you multiply all the numerators, you will get log xyz the whole square upon log xyz. And once we have this, the power will again come out, I mean come at the beginning part. So that 2 xyz raised to 2, that 2 will come at the starting part, and it will be 2 log xyz, and then log xyz will be cancelled. So the answer of this simplification is 2, which is option 2. The third one, find the value of 7 upon 1 plus log xy to the base z plus 7 upon 1 plus log xz to the base y plus 7 upon 1 plus log yz to the base x. Again, you can do the same thing, apply change of base, restructure, cross multiply. You'll realize all the denominators will be same, which is log xyz, and all the numerators will be 7 log z plus 7 log y plus 7 log x. All the denominators are same, so numerator should also be added, but in logs we don't add the numerators, we'll multiply them. So it will be 7 log xyz upon log xyz. Log xyz from both numerator and denominator will cancel out. You'll get 7 as the answer. That is one way to look at this. The second way is substitute the values of xyz as 10 each, simplify, again you'll get the answer. And then there is a third approach which we are going to see right now. You'll need to start simplify. So when we use change of base and log properties effectively, in the first term, because the base of log is z, so the one that is in the beginning in the denominator, we are writing it as log z to the base z. Similarly, for the second term, we'll write that one as log y to the base y. And for the last term, we'll write that one as log x to the base x. So now the bases are same. So we should just simply add, but log mein add nahi hota. We'll then multiply them. And now this is what we will get. Cancel this out. You will get 7 as the answer. So three approaches to simplify this question. I mean, after this step, the second step, 7 upon log xyz to the base z, you could have also done change of base and you would have gotten what I was trying to tell you in the beginning. Or you would have think of this as well. You reverse it and then you have log xyz to the base xyz, which will again get cancelled and you will get 1. So 7 into 1 is 7. Fourth one, this one, and I think seventh one. These are the only two tough questions from this entire sheets. Otherwise, the rest all are very manageable. The reason that they are slightly trickier than the other few questions that we are discussing today, because of adjustments and a lot of other things, extra additional factors that come into the picture while getting the final answer. And you'll understand that. So what we have, 1 by 3 log m to the base 3 plus 3 log n to the base 3 is equal to 1 plus log 5 to the base 0.008. Then which of the following expressions will be holding true? So we'll need to simplify this first. What we can do is, if we simplify the left hand side, again you are seeing that 1 by 3 and 3 has come at the starting part, and try to think of a one step before that step, that why these numbers are ahead. So obviously they should have been in the powers in the previous step. So you can say that log m raised to 1 by 3 to the base 3 plus log n cube to the base 3 is equal to this entire part. And then again, the base is also same. So it is as good as log a plus log b. And we know that we will have to multiply that. So it will be log ab. So log m raised to 1 by 3 into n cube to the base 3 is the simplification after a couple of steps on the left side. On the right side, the first thing that you should do is use change of base. So when you use change of base, you will get 1 plus log 5 upon log 0.008. And that 0.008 can be rewritten as 0.2 cube. Then what will happen? That 0.2 raised to 3, the power of 3 will come ahead, and you will get this 1 plus 1 upon 3 log 5 upon log 0.2. And that 0.2 can be also rewritten as 1 by 5. Now, why we have done that? Instead of 0.2, we have written 1 by 5, because then when you see that term, what you realize is you have log 5 upon log 1 by 5. And please remember this as a property going forward, that log of x upon log of inverse of that is 1 upon x. The answer to that is always minus 1. So log 5 upon log 1 by 5, answer is minus 1. So log of some number upon log of reciprocal of that same number, answer is always going to be minus 1. So you'll have 1 minus 1 by 3 on the right side, which is 2 by 3. And that is the simplification of the right side. Now, once the right side is simplified entirely, now we need to get rid of that log to the base 3 on the left side. And this is where we need the definition, the transition from the log form to the index form. Yeah, index form to the log form, vice versa, if you can understand. Both are one and the same thing. So the way you had defined the index form and the log form in the definition while doing the important part. So whatever is the base of log, you are going to do raise 2 of that on the right side. So base is 3. So when you get rid of log and convert it to index form, you will get m raised to 1 by 3 into n cube is 3 raised to 2 by 3 is equal to 3 raised to 2 by 3. Why 3 raised to 2 by 3? Because 3 was the base of the log on the left side, if you can see. Now, to simplify this, obviously, let's take cube on both the sides. So again, we'll use laws of indices that we have discussed in the previous classes. So when you apply laws of indices, the powers will get readjusted and you will have m into n raised to 9 is equal to 3 raised to 2 because 2 by 3 wala 3 and raised to 3 wala 3 will get cancelled and you will have 3 square, which is 9. So m into n raised to 9 is equal to 9. Again, when you restructure that, you get n raised to 9 is 9 upon m. And this is the answer which is present in option 2. So fourth question, answer is this is how you can solve this question. The fifth one, find the sum of first 10 terms of the series. So there is a pattern clearly. All the numerators, if you see, they are powers of 2. All the denominators, if you see, they are powers of 5. But the first term, it has a denominator of 1, which is 5 raised to 0. So first of all, for the 10th term will be log of 2 raised to 10 upon 5 raised to 9. Now, again, what will happen is in the log, we can't add them. We'll have to multiply. So in the numerator, it is powers of 2. In the denominator, it is powers of 5. Then laws of indices, base is same, powers are in multiplication, then the power should be added. So in the numerator, it will be 2 raised to 1 plus 2 plus 3 plus 4, so on till 10. So 1 to 10 ka sum. In the denominator, it will be 5 raised to 0 plus 1 plus 2, so on till 9. That is 1 to 9 ka sum. So in the numerator, you will have 2 raised to 55 because 1 to 10 ka sum is 55. And in the denominator, you will have 0 to 9 ka sum, which is 45, which is 5 raised to 45. So you have now log of A upon B. So it is in division, so it should be subtracted. That will be log of 2 raised to 55 minus log of 5 raised to 45. Use the power wala property, take the powers ahead. So it will be 55 log 2 minus 45. Again, this is not present. So what else that you can do is take out something common from both the terms. You'll be left with 5 times 11 log 2 minus 9 log 5 as the answer of this simplification, which is option 3 for the fifth question. The sixth one, how many digits will the number 3 raised to 500 will have if the log of 3 is given? So this is where that characteristic and mantissa wala concept will come. So 3 raised to 500 usually will be a pretty high and a huge number, big number. We won't be able to manually calculate the number of digits. And this is where logs application comes very handy. So what you remember is take a log on both the sides. So take log on 3 raised to 500. So again, the power wala property, 500 will come ahead. You will get 500 log 3. We know the value of log 3, which is given in the data itself, which is 0.4771. So 500 multiplied with 0.4771, you get 238.55. So in this part, characteristic is the integer part of the answer, which is 238. And mantissa is the decimal part of the answer, which is zero point 0.5. So always remember a formula, folks. For calculating the number of digits, what you do is whatever is your characteristic, which is the integer part of the answer, always add 1 to that. So 238 is the characteristic. If we add 1 to that, the final answer that we'll get is 239. So 3 raised to 500 will have in totality 239 number of digits. Imagine such a big number. And this is the beauty of logs, that it can just drastically simplify such complicated questions. The seventh one, the second toughest question. There's a big equation where x is the real number, and then there is another equation, x raised to u is equal to 256. And this has either no solution for x, or exactly one solution for x, or exactly solutions for x, and so on henceforth. So what you do is for this one, I mean, there are two approaches. Either you actually solve this and get the answer, or there's a smarter way, which I'm more interested in discussing that. So what you do is you begin with the second equation, that is x raised to u is equal to 256. And when you begin with that equation, what you have to do is try and figure out such values of x and u which will satisfy this relation. Try and figure out such values of x and u which will satisfy this equation. So when you do that, what you will get is 16 square is 256. So x is 16, u is 2, or 4 is to 4, or 2 raised to 8, or 256 raised to 1. So four values of x and u are the ones that satisfy this first equation. And then what you will now have to do is, by trial and error, substitute all these values of x and u one by one in that other bigger equation as well, which is this one. And when you do that, you will realize only one set of value that satisfies, which is x and u both are equal to 4. No other value of x and u will satisfy this other equation. Only and only because of that will mark answer option 2, which says exactly one solution for x for this equation. And hence, this was a very important and a tricky question. So these are some of the things that you need to think of by going out of the box, basically. The last one, log 2 is given, log 3 is given, and we have to figure out the value of 5 and log of 512 to the base 5. So first use change of base, and you will get log 512 upon log 5. Log 512 can be written as 2 raised to 9, and then use the power wala property. So 9 will come ahead, and you'll get 9 log 2 upon log 5. Now log 2 the value is given, but log 5 students usually say log 3 minus log 2, which is wrong because log maybe don't add if you remember. So this is where the adjustment comes into the play. In the place of 5, you could have written 10 by 2, and then that becomes log of 10 upon 2. So use division wala property, which is subtraction, and hence we get log 10 minus log 2. So folks, here the examiner has given log 3 ka value just to distract us from the real thing, and we will, and some of us will definitely make that mistake of writing log 5 as log 3 minus log 2, which is what we should not be doing. So actually 5 ke jagah pe we should have done 10 upon 2. Log 10 is 1, log 2 ka value is known to us, which is 0.010. Substitute in the appropriate places. In the denominator you will have 1 minus 0.3010, which is 0.6990, and in the numerator you have 9 into 0.3010. All of that calculation will give you the final answer of this question as 3.87, which is option first. So eighth question, option first. So you would have realized except one or two specific tough questions, majority of the other questions are purely based on the formula and the properties that we would have covered in the concepts. So the main part is you remember those very nicely first, and then only you'll be able to understand all these solutions, because after one point of time there will not be any new varieties apart from change in the numbers. So hence this is one of those topics that you should never ever skip, no matter how difficult you think that it is, because it actually has a lot of limitations in terms of how the examiner can twist and turn this. People get scared seeing logs, but it is not the case so far. So folks, we'll stop here for today. If you have any questions, let us know. Thank you so much.